Today we'll discuss Indian Statistical Institute's B Math and B Stat 2017 paper. Now this paper again, it is absolute fun and sheer delight. So let us straight away start with the questions. Now the first question is, consider a quadratic equation ax square plus 2bx plus c equals 0, where a, b, c are positive real numbers. Then if this equation has no real roots, then which of the following options is true? Now we know that any quadratic equation has no roots when d is less than 0. So if I write d, it will be simply 4b square minus 4ac is less than 0. That is, b square is less than ac. Now since b square is less than ac, that means b square cannot be equal to ac. So a, b and c, they cannot be in GP. Now what about AP? Now condition for an AP is a plus c by 2 is equal to b. Now in the question it says this b is less than under root ac, so it is less than root ac. So I can write this as a plus c is less than twice under root ac, or I can write it as under root a square plus under root c square minus 2 times under root ac is less than 0, and I'll get under root a minus under root c whole square. It is less than 0. Now square of any real number, it cannot be less than 0. So it is an impossible condition. So these three numbers, they cannot be in AP also. Now what about HP? We know that condition of HP is B should be twice AC upon A plus C, and I can write it as AC upon A plus C by 2. Now we know that AM is greater than GM, so I can write A plus C by 2 is greater than under root of AC, or I can say 1 upon A plus C by 2 is less than 1 upon under root AC. So if I'll multiply it with AC on both sides, then I can write AC upon A plus C by 2 is less than under root of AC. So from this condition of HP, the result I'm getting is B should be less than under root of AC, which is possible with the given condition, which is B square is less than AC. So these three numbers, they cannot be in AP, they cannot be in GP, but they can be in HP. So answer to this question is option number C. Now in question number 2, it says a unit square has its corners chopped off to form a regular polygon with 8 sides. So I'll draw a square. Now 4 corners are chopped off. So if we chop off 4 corners, then we'll get this regular polygon, and suppose this length is x. Now it is given that it is a unit square, so length of this side is 1 unit. That means length of this side of a polygon will be 1 minus 2x. Now in this right angle triangle, I can find this hypotenuse, and it is root 2x. Now since it is a regular polygon, then length of these two sides, it should be same. So the condition I'll get is root 2x is equal to 1 minus 2x. Then from here I'll write 2 plus root 2 into x is equal to 1, or x is 1 upon, I'll take root 2 common, and then root 2 plus 1. So if I'll rationalize it, I'll write root 2 minus 1 upon root 2 minus 1. Then the value of x is simply root 2 minus 1 upon root 2, or I'll simply write it as 1 minus 1 upon root 2. Now it says we need to find area of this polygon. So basically area of this polygon will be area of this square, which is 1 square, minus 4 times area of this small triangle. So minus 4 times, and what is the area of this small triangle? It is half x into x. So it will be simply 1 minus 2 into x square. What is x square? X square is 1 minus 1 by root 2 whole square. So I'll get 1 minus 2, 1 plus 1 upon 2, and then minus root 2. So I'll write it as 1 minus 2 minus 1 plus 2 root 2. So I'll take 2 common. So then it will be 2 into root 2 minus 1. So area of this polygon is 2 root 2 minus 2, and that's your option number B. Now question number 3, it says a solid cube of side 5 centimeters has all its faces painted. The cube is sliced into smaller cubes, each of side 1 centimeter. Then how many of these smaller cubes will have paint on exactly one of its faces? Now we know that the volume of this cube is 5 into 5 into 5, that is 125. And if we'll slice it in smaller cubes, then we'll have 125 small cubes. Now out of these 125 small cubes, we need to find out how many cubes are there which will have paint on exactly one of its faces. Now if a cube has a paint on one of its faces, then it must lie on one of the faces of this bigger cube. So if we'll consider any one face, say for example this face, then all these 4 corner cubes, they are shared by 3 faces. So all these 4 cornered cubes, they will have paint on exactly 3 faces. Now what about cubes on the edges? On the edges, each cube is shared by 2 faces. So these 12 cubes on the edges, they will have paint on exactly 2 faces. Now these remaining 9 cubes on each face, they are the ones which will have paint on exactly one of its face. So on this face, we'll have 9 cubes. Similarly, we'll have 9 cubes in all of the faces. So total number of smaller cubes that will have paint on exactly one of its faces will be 9 into 6, and that is 54, and that's your option number B. Now question number 4, it says Z is a complex number such that Z minus iota upon Z minus 1 is purely imaginary. So that means real part of Z minus iota upon Z minus 1, it should be 0. So I'll take this Z as x plus iota y. So I'll write x plus iota y minus 1 and x minus 1 plus iota y. Now I'll multiply and divide it with x minus 1 minus iota y upon x minus 1 minus iota y, and I need to find a real part of this complex number, and it should be 0. Now I'll get real part when this x gets multiplied with x minus 1 and when y minus 1 gets multiplied with minus iota y. So if I'll multiply, I'll get x into x minus 1 plus y into y minus 1 equals to 0. So that is this complex number z, it will lie on this circle which is x square plus y square minus x minus y equals to 0. Center of this circle is at 1 by 2 comma 1 by 2, and radius of this circle is simply 1 by root 2. Now for this circle whose center is at 1 by 2 comma 1 by 2 and whose radius is 1 by root 2, we are given a point which is 2 comma 2. Now we need to find minimum value of z minus 2 plus 2 iota, then it simply means we have to find the point which is closest to this given point. Basically in complex numbers, modulus value is distance between two numbers. So in this case, mod of z minus 2 plus 2 iota is distance of these points on this circle from this given point which is 2 plus 2 iota. Now the point which is on the circle and which is closest to 2 plus 2 iota is the point which lies on line joining the center and this given point 2 plus 2 iota. So now the minimum value of z minus 2 plus 2 iota is this distance. Now how do we find this distance? So first we'll calculate this distance, and from this distance if we'll subtract radius of this circle, we'll find the minimum value of mod z minus 2 plus 2 iota. So we'll find this distance L. So this distance L will be 2 minus 1 by 2 square, 2 minus 1 by 2 square, which is 3 by root 2. And what is the radius of this circle? Radius of this circle is simply 1 by root 2. So the minimum value of mod z minus 2 plus 2 iota will be L minus r, which is simply equal to root 2, and that's your option B. Now question number 5, it's a very standard differentiability question. Now it says, let fx be a continuous function such that for any two real x and y, mod of fx minus fy is always less than 7 into mod of x minus y to the power 201. So I can also write it as mod of fx minus fy upon x minus y is less than equal to 7 into mod of x minus y to the power 200 for any real x and y. Now what I'll also do is I'll take this limit y tends to x. So if I'll take this limit y tends to x, then this left hand side is actually nothing but it is simply mod of f dash x, and it is less than or equal to, now x minus x is simply 0. So that is the condition that I'm getting. Now we know that absolute value of any real function cannot be negative. So the only condition that I'll have here is this f dash x should be equal to 0 because it cannot take a negative value. Now if f dash x is 0, it simply means fx is a constant function. So this function fx, it is a constant function. Now if fx is a constant function, it simply means f101 is equal to f202 is equal to f201 is equal to f200. So none of these three options A, B and C, they hold. So answer is simply D, which is none of the above. Now question number 6 says, in the mathematics department of a college, there are 60 first year students, 84 second year students and 108 third year students. All these students are to be divided into project groups such that each group has same number of first year students, the same number of second year students and the same number of third year students. What is the smallest possible size of each group? So it is a very simple question. Here in this question, we'll have to find a number which divides all the three given numbers. So basically we have to find HCF of these three given numbers: 60, 84 and 108. Now we know that 60 is 2 square into 3 into 5. 84 is 2 square into 3 into 7. And 108 is 2 square into 3 cube. So the number which is common in all the three is 2 square into 3, which is 12. So now we know that all these numbers, they are divisible by 12. And once all these numbers, they are divisible by 12, it simply means we can divide all these students in first year in 12 groups, each group containing 60 by 12, that is 5 students. In the same way, we can write it for second year students. So we have altogether 84 students, and if we divide them in 12 groups, it will be 7 students in each group. And then finally, for third year students, it will be 108 divided by 12, and there will be simply 9 students. So that means in each group, there will be 5 students from first year, 7 students from second year, and 9 students from third year. So if we'll add them, then smallest possible size for each group will be 21, and that's your option number D. Now in question number 7, it says there are 3 numbers A, B and C and each greater than 1 such that 2 by 3 log A base B plus 3 by 5 log B base C plus log C base A 5 by 2 is equal to 3, and it is given that if the value of B is 9, we need to find value of A. Now what I'll do is I'll write arithmetic mean for these 3 numbers. So for these 3 numbers, arithmetic mean is given by 2 by 3 log A base B plus 3 by 5 log B base C plus 5 by 2 log C base A whole divided by 3. Now in the question it says sum of these 3 numbers is 3. So 3 divided by 3 is simply 1. So arithmetic mean of these 3 positive numbers is simply 1. Now what about their geometric mean? So their geometric mean will be 2 by 3 log a base b into 3 by 5 log b base c into 5 by 2 into log c base a to the power 1 by 3. Now here 3 will cancel, 5 will cancel, and 2 will also cancel. Now this log a base b, it is simply log a upon log b. This is log b upon log c, and this is log c upon log a. So here also everything gets cancelled. So geometric mean for these three numbers is also 1. So that means I'm getting this condition where arithmetic mean is same as geometric mean for these three given numbers. Now we know that arithmetic mean is equal to geometric mean only when all the numbers are equal. So that means the condition I'm getting is this 2 by 3 log a base b is equal to 3 by 5 log b base c is equal to 5 by 2 log c base a. Now what I'll also do is I'll change everything to the base 3. So I'll write 2 by 3 log a base 3 upon log b base 3, 3 by 5 log b base 3 upon log c base 3, and this is 5 by 2 log c base 3 upon log a base 3. Now this log b base 3 is actually log, now value of b is 9 and 9 is simply 3 square. So log b base 3 is 2. So I'll put the value of log b base 3. So I'll write it as 2 by 3 log a base 3 upon 2. This is equal to 3 by 5 and this is 2 upon log c base 3 and this is 5 by 2 log c base 3 upon log a base 3. Now if I'll simplify these first two expressions, then from here I'll write log a base 3 into log c base 3, and this value will be equal to 18 by 5. Now if I'll take this first one and third one, from here I'll write log a base 3 whole square upon log c base 3, and this value will be equal to 15 by 2. Now I'll multiply these two. So if I'll multiply them, then I can write it as log a log c into log a whole square upon log c, and this is 18 upon 5 into 15 upon 2. Here log c will cancel, so I'll get log a base 3 whole cube, and this is equal to, so this is 9 and this is 3, so it'll be 27. So from here I'll write log a base 3 is equal to 3. So if I'll take anti-log, then I can simply write value of a is simply 27, and that's your option number D. Now in question number 8 it says there is a triangle ABC and the sides AB and AC are extended to points D and E so that AD is 3 times of AB and AE is 3 times of AC. Then we need to find the ratio in which one diagonal of BDEC divides the other diagonal. So I'll consider this triangle ABC and then I'll extend the sides. So suppose this is A, B and C, and that's your D and E. Now let A be origin and let position vector of B be this B vector and position vector of this point C is this C vector. Now it says AD is 3 times of AB. So that means position vector of D will be simply 3B and position vector of E in the same way will be 3C. Now consider this quadrilateral BDEC. Now if I'll draw the two diagonals, they'll intersect at some point P, and suppose these two diagonals, they divide each other in the ratio lambda is to 1 and suppose 1 is to mu. Now from these points D and C, if I'll use section formula, then I can write position vector for this point P will be lambda C plus 3B upon lambda plus 1. And if I'll use these points B and E, then the position vector of this point P will be 3C plus mu B upon mu plus 1. Now this point P, it's the same point, right? So from here, I'll write this condition, which is lambda C plus 3B upon lambda plus 1 must be equal to 3C plus mu B upon mu plus 1. Now these two vectors, B and C, they are non-collinear. So if the vectors are non-collinear, then their coefficients must be same. So if I'll compare coefficients of C, I'll write lambda upon lambda plus 1 is equal to 3 upon mu plus 1. And if I'll compare coefficients of B, I'll write 3 upon lambda plus 1 is equal to mu upon mu plus 1. So from the symmetry of the problem, I can say this lambda, it must be equal to mu. So we'll consider lambda and mu equal. Then I'll get lambda upon lambda plus 1 equals 3 upon lambda plus 1. So that means value of lambda is equal to value of mu, and this is equal to 3. So these diagonals, they'll divide each other in the ratio 1:3 or 3:1. That's your option number A. Now this question number 9, it says the area of region bounded by the curve y equals 10x, the x-axis, and tangent to the curve y equals 10x at x equals pi by 4. So I'll draw this graph. So I'll draw the graph of 10x. Now suppose this point is pi by 4. So I'll draw the tangent at pi by 4. So we'll need to find area bounded by this curve x-axis and this tangent at pi by 4. Now this point is pi by 4, 1. So first I'll find equation of tangent at this point P. So y is 10x. What's dy by dx? dy by dx is simply secant square x. So dy by dx at this point P will be secant square pi by 4, and there'll be 2. So if I write equation of this tangent will be y minus 1 equals 2 into x minus pi by 4. So equation of this line is y equals 2x minus pi by 2 plus 1. Now we need to find this area. Now for this area, what I'll do is I'll find the area bounded by is 10x and x-axis, and suppose this area, it is A1. So I'll find this A1 area. So here A1 is simply this integral from 0 to pi by 4 10x dx, and which is log mod secant x from 0 to pi by 4, and it will be simply log and then root 2. So it is 1 by 2 ln 2. Now secondly, I'll find area of this triangle, which is area between this tangent and x-axis, and for that I need to find this point of intersection of this tangent with x-axis. Now for x-axis, I'll put y as 0. So if I'll put y as 0, I'll get x as pi by 4 minus 1 by 2. So this point of intersection of this tangent with x-axis is simply pi by 4 minus 1 by 2 comma 0. So what is the area of this triangle? So area of this triangle, it simply is 1 by 2. And what is the height? Height here is 1. And then what is this length? This length is 1 by 2. So this area is 1 by 4. So now we can write area of the region that we'll need. So area of this region, which is bounded by this curve x-axis and this given tangent, is simply A1 minus this area of small triangle. So A1 is 1 by 2 ln 2, and this is minus 1 by 4. So I'll take 1 by 2 common. So I'll get it as ln 2 minus 1 by 2, and that's your option number C. Now question number 10 says, let V be set of vertices of a regular polygon with 20 sides. If 3 distinct vertices are chosen at random from V, find the probability that the chosen triplet are vertices of a right angle triangle. Now first we will find total number of elements in this sample space, which is how many triangles can be formed from the vertices of this given polygon. So there are 20 vertices. So number of triangles that can be formed is simply 20C3. And we need to find number of elements in favorable cases. That is, we need to find how many right angle triangles can be formed. So what I can do is, if I choose any 2 points which are diametrically opposite to each other, so if I take any other point, then we know that angle in a semicircle is simply 90 degrees. So it means if I have to form a right angle triangle, then I have to choose 2 vertices which are diametrically opposite. Then I can choose the third vertex from the remaining vertices. So in how many ways can I choose these 2 diametrically opposite vertices? So overall there are 20 points. So there'll be exactly 10 pairs of diametrically opposite points. Suppose the event that the triangle formed as a right angle triangle is A, then NA will be. So first I'll choose diametrically opposite points, so which can be done in 10C1 ways. Now once I have these 2 points, then I can choose any one point from the remaining 18 points. So from remaining 18, if I have to choose one, I can write it as 18C1. So probability of getting a right angle triangle will be simply 10C1 into 18C1 upon 20C3. Now this is 10 into 18, and this is 20 into 19 into 18, and this is 6. So I'll cancel it. So this is 3. So this probability is equal to 3 by 19, and that's your option number B. Now in question number 11 it says, a basic row operation is defined as adding a multiple of one row to another row. Now it says, consider the matrices A and B. It is given that B can be obtained from A by applying finitely many basic row operations. Now here we are not talking about elementary row transformations. Here we are talking about just one transformation, that is adding a multiple of one row to another row. It is a very common property of determinant that if we add a multiple of one row to another row, then the value of determinant does not change. Since we are applying this transformation finitely, then we can simply say that determinant of A must be equal to determinant of B. So all I need to do in this question is I'll need to find determinant of A and I'll need to find determinant of B, and then I'll just need to equate them. So first I'll find determinant of A. So determinant of A will be, this is X, it is 6 minus 4, which is 2, and then minus 5, it'll be 2, and then minus 2, so there'll be minus 2, and then plus X, it'll be minus 2 plus 6, so that is 4, so I'll get it as 6x plus 10. So determinant of A is 6x plus 10. What is determinant of B? Determinant of B is 21 into 4 by 3, and that is 28. So I'll put the value of determinant A and determinant B. So determinant A is simply 6x plus 10 and determinant of B is 28. So 6x equals 18. So value of x is simply 3. So answer to this question is 3, which is option number A. Now question number 12 says, let C be a circle of area A with center at O. So I'll say, suppose this C is x square plus y square equals r square. Now center is origin, which is O, and what is area? Area is pi r square equals A. So I can write r square as simply A upon pi. So equation of this circle is x square plus y square equals A upon pi. Now it says, suppose there is a point P such that distance of this point from origin is twice the length of tangent drawn from P to the circle. So condition given is this OP is 2 times length of tangent. Now we need to find locus of this point P. So what I'll do is I'll let this point P as alpha comma beta. Now what's OP? OP is simply distance from origin, so it will be under root of alpha square plus beta square and 2. Now what is length of tangent? Length of tangent is simply under root of S1. So it will be under root of alpha square plus beta square, and this is 2, and here will be under root of alpha square plus beta square minus a upon pi. So if I'll square it, I'll write it as alpha square plus beta square is 4 alpha square plus beta square and minus 4a upon pi. So I'll write it as alpha square plus beta square equals 4a upon 3 pi. This point P, it will lie on this circle, which is x square plus y square equals 4a upon 3 pi. Now center of this circle is at origin again, and its radius will be under root of 4a upon 3 pi. So area of this circle simply will be 4a by 3. So answer to this question is, it represents a circle which centered at O with area as 4 by 3a. That's your option number C. Now question number 13, it says a moving line intersects the line x plus y equals to 0 and the other line x minus y equals to 0 at the points A and B. So we have two perpendicular lines. So one of the line is x plus y equals to 0 and the other line is x minus y equals to 0, and then we have this moving line L equals to 0 which intersects these two lines at points A and B. So now A will lie on this first line, so I'll assume this as h comma minus h, and B will lie on this line x minus y, so I'll say suppose B is k comma k. Now it says area of the triangle with origin A and B has a constant area C. So I'll find this area. Area of this triangle will be 1 by 2 and then 0, 0, 1, h minus h and then 1 and then k and 1, and this area is equal to plus or minus C. So if I'll expand, then I'll get hk equals plus or minus C, or I can write hk square is equal to C square. So that's my first equation. I'll need to find locus of midpoint of AB. So suppose this point is alpha comma beta. Using midpoint formula, I'll write alpha as h plus k upon 2 and beta as minus h plus k upon 2. So if I'll square them and subtract them, then I'll get alpha square minus beta square equals h into k. So if I'll square it again, I can write alpha square minus beta square whole square is equal to hk whole square, and hk whole square is simply c square. So locus of this midpoint will be simply x square minus y square whole square, and this is equal to c square, and that's your option number B. Now in question number 14, we are given two sets A and B, and we need to find number of functions from A to B such that for every x belongs to A, there is 1 and exactly 1 y with y unequal to x and fx equals f. That means for each and every element, there must exist another element such that the value at x must be same as value at y. So that means for these 6 elements, we need to form 3 pairs. And 2 elements in the given same pair, they must be mapped to same element. So that's how we can fulfill this condition that for every x, there is 1 and exactly 1 value of y. So first thing, what I need to do is I need to distribute these 6 points in the pair of 2, 2 and 2. So in how many ways can it be done? So it can be done in factorial 6 upon factorial 2 whole cube upon factorial 3. So now what we have done is we have distributed these 6 points in a group of 2, 2 and 2. Now we need to find image of these 3 groups. So for the image of these 3 groups, we need to choose 3 elements from this given set B. Now out of these 5 elements, we can choose 3 elements in simply 5C 3 ways. Now we have 3 groups and we have 3 elements. Now we need to map these groups with these given images. So now these 3 groups in A can be mapped to these three elements in B in simply factorial 3 ways. So the total number of such functions will be factorial 6 upon factorial 2 cube, factorial 3, 5c3 into factorial 3. Now factorial 3 will cancel. Now this is factorial 6, factorial 2 cube is 8 and 5c3 is 10. So this is 720 into 10 divided by 8, which is simply 900. So number of such functions is simply 900, which is option number C. Now question number 15 says, two persons both of height h are standing at a distance of h from each other. So there are two people and they are of the same height h and distance between them is also h. So this is h, this is also h, and this distance is also h. Now it says, shadow of one person cast by a vertical lamp post placed between two persons is double the length of shadow of other. So that means we have this lamp post which is standing somewhere between these two persons. Now suppose height of this lamp post is L and it is placed at a distance of x from this first person. So this distance simply will be h minus x. Now it says shadow of these two people. So we'll find these shadows. Now we'll find shadows of these two. So suppose this shadow is simply S, then this shadow is simply 2S. Now it also says sum of length of the shadows is h. So that means 3s is equal to h. So value of s is h by 3. So this is h by 3 and this is 2h by 3. Now we need to find height of the lamp post. So we need to find this L. Now first I'll consider these two similar triangles. Now for these two similar triangles I can write h by 3 upon h by 3 plus x is equal to h upon L. So here h will cancel. So I can write L upon 3 equals h upon 3 plus x. So from here I'll write x equals L minus h upon 3. So that's my first result. Now I'll consider this second pair of similar triangles. So for this similar triangles I can write 2h upon 3 upon 2h upon 3 plus h minus x, and this is equal to h by L. So here h and h will cancel. So I'll get 2L is equal to 2h plus 3h minus 3x. So from here I'll write x as 5h minus 2L by 3, and that's my second equation. Now I'll eliminate this x. So if I'll eliminate this x, I'll write L minus h upon 3 is equal to 5h minus 2L upon 3. So from here I'll write 3L equals 6h. So basically L is equal to 2h. So height of this lamp post is 2 times the height of these person. So answer to this question is simply B. Now question number 16, it says, let S be set of all points Z in the complex plane such that 1 plus 1 upon Z to the power 4 is equal to 1. So I can write 1 plus 1 upon Z as 1 to the power 1 by 4, and this is e to the power iota 2k pi by 4, where k is 0, 1, 2 and 3. So basically it is 4th root of unity. So now I can write 1 upon Z as e to the power iota 2k pi by 4 minus 1, and then if I'll take this reciprocal, then I can write Z as 1 upon e to the power iota 2k pi by 4 and minus 1. Now what I'll do is I'll divide this numerator and denominator with e to the power iota k pi by 4. So if I'll divide it with e to the power iota k pi by 4, in the numerator I'll get e to the power minus iota k pi by 4 upon e to the power iota k pi by 4 and minus e to the power iota minus k pi by 4. Now e to the power iota theta is cos theta plus iota sin theta. So in the numerator I'll get cos k pi by 4 minus iota sin k pi by 4, and in the denominator e to the power iota theta is cos theta plus iota sin theta, and minus e to the power minus iota theta is cos theta minus iota sin theta. So here cos theta will cancel, so I'll get 2 iota sin k pi by 4. So I can write this complex number z as 1 upon 2 iota cot k pi by 4 and then minus 1 by 2. So this complex number z is minus 1 by 2 and then minus 1 upon 2 iota cot k pi by 4. Now all these four complex numbers, they have their real parts as minus 1 by 2. So all these four complex numbers, they lie on this line which is z equals minus 1 by 2. So that means all these 4 points in this complex plane, they are collinear. Now question number 17 says a circular lawn of diameter 20 meters in a horizontal plane is to be illuminated by a light source placed vertically above the center of the lawn. So I have this circular lawn. Diameter is 20, so that means radius is 10. So this radius, it is 10 meters. Now we have this light source which is placed vertically above, and suppose it is placed at this height h. Now it is known that illuminance at any point P on the lawn is given by this formula I equals c sin theta upon d square for some constant c, where d is distance of P from light source, theta is angle between the line joining the center of the lawn to P and line joining the light source to P. We need to find maximum possible illuminance at a point on circumference of the lawn. So I'll take this point P. Now this angle, it is theta, and this angle is 90 degrees, and this length is d. Now illuminance at any point P is given by c sin theta upon d square. Now we need to express this d in terms of theta. So we know that d cos theta is 10. So basically d is 10 upon cos theta. So I can write this illuminance at point P as c sin theta into cos square theta divided by 100. So now in order to maximize illuminance, I'll differentiate. So I'll find di by d theta. So it'll be c upon 100 and then sin theta as it is. Now this is 2 cos theta and then minus sin theta and plus cos square theta, derivative of sin theta is cos theta. I'll put it equals to 0. So now here I can take cos theta common. So I'll write c by 100 into cos theta, and here I'll get minus 2 sin square theta and plus cos square theta equals 0. So from here I'll get two conditions. Either the value of cos theta is 0 or the value of tan theta is 1 by root 2. Cos theta is 0 when theta is pi by 2, and this theta will be pi by 2 when this source is placed at infinite. So if the source is placed at infinite, in that case we'll get this illuminance which is nearly 0. That's the minimum value of illuminance. For maximizing this illuminance, we'll get tan theta as 1 by root 2. So we have this right angle triangle. This is theta, this is 1, this is root 2, and here it is root 3. So what is the maximum possible value of this illuminance? Maximum value of this illuminance will be, so it is c by 100 and then sin theta. Sin theta is 1 by root 3 and then cos square theta. Cos square theta is simply 2 by 3. So which is c upon 150 root 3, and that's your option number C. Now question number 18, it says let fx and gx be two real valued continuous functions defined on closed interval a and b such that fa is less than ga and fb is greater than gb. Suppose we have this function gx, and then suppose we have this function which is fx. Now at x equal to a, f is less than b, and at some other point b, fb is greater than gb. Now it says we need to find area enclosed between the graph of two given functions and line x equal to a and x equal to b. Now we calculate this area by taking this integral, which is, suppose this point is c, so I'll write it as from a to c, y of upper curve. Now in this case it is g minus f into dx, and then plus from c to b, I'll write f minus g into dx. Here upper curve is g, lower curve is f, and here upper curve is f and lower curve is g. So that means in each of the cases, all I'm taking is I'm taking the difference of the two given functions. But then this difference of two functions, it may be positive and it may be negative. Another way of writing this function can be, I can write this function as from a to b and then mod of f minus g into dx. So if I write this mod of f minus g, so at any point of intersection, it will automatically change its sign and make this difference positive, which is option number A. Now in question number 19, this function f is defined as x minus 1 into minimum of x or x square when x is greater than or equal to 0, and x into minimum of x or 1 by x when x is less than 0. So when x is greater than 0, if I'll draw the graph of y is equal to x and y is equal to x square, so this is y is equal to x line, and this is y is equal to x square. So between 0 and 1, the function which is minimum is x square, and between 1 and infinite, minimum function is x. So I can write this function fx as x into x minus 1 when x is greater than 1, and this is x square into x minus 1 when x lies between 0 and 1. Now when x is less than 0, I need to consider minimum of x and 1 by x. So when x is less than 0, we have this 1 by x, and then we have this y equals x, and their point of intersection will be minus 1. So between minus 1 and 0, this minimum value will be 1 by x, and when x is less than minus 1, this minimum value will be x. So I can write this as, so between minus 1 and 0, in that case, minimum is 1 by x. So 1 by x into x is simply 1. And when x is less than minus 1, here the minimum value is simply x. So now it will be simply x squared. Now I'll need to find continuity and differentiability of this function. So if I'll put x as 1, it will be 0. At 1, here also it will be 0. So it is continuous at 1. So if I'll put x as 0, I'll get this as 0. But if I'll put x as 0 here, it is 1. So it is discontinuous at x equal to 0. Now at minus 1, this value is 1. And at minus 1, this value is again 1. So this function is continuous at all points except at x equal to 0. Now I'll differentiate this function. So if I'll find f dash x, I'll write this as 2x minus 1 when x is greater than 1, 3x square minus 2x when x lies between 0 and 1. This is 0 when x lies between minus 1 and 0, and this is 2x when x is less than minus 1. Now when x is greater than 1, so if I'll put x as 1, I'll get this value as 1. So that means right hand derivative at 1 is 1. And if I'll put x as 1 here, I'll get 3 minus 2, which is 1 again. So that means this function is differentiable at x equal to 1. Now what about 0? Now we already know this function is discontinuous at x equal to 0. Now we know that if a function is discontinuous at a point, then it is not differentiable at that point. So that means this function is not differentiable at x equal to 0. Now what about minus 1? So at minus 1, right hand derivative is 0, left hand derivative is minus 2. So that means it is also not differentiable at x equal to minus 1. So this function is not differentiable at 0 and minus 1. So that means answer to this question is not differentiable at exactly 2 points. Now in question number 20, we are given this function f such that 1 by 2, this integral from 0 to 2, fx dx is less than f2. Then we need to find which of the following statement must be true. So what I'll do is, I'll define a function gt, and I'll define this function as from 0 to t fx dx when t lies between 0 and 2. Now it is given that this f, it is a continuous function. So integration of a continuous function is a continuous function. So this function gt, it is continuous and differentiable. Now if a function is continuous and differentiable, then we can use Lagrange's mean value theorem in the interval 0 to 2. Now Lagrange's mean value theorem says there must exist a point C in the open interval 0, 2 such that g dash c is equal to g2 minus g0 upon 2 minus 0. Now if I differentiate this function, I can write g dash t as simply ft. So that means g dash c will be fc. So it simply means there exists a point c in this open interval 0, 2 such that this fc is equal to g2. And what's g2? G2 is this integral from 0 to 2 fx dx minus what is g0? Integral from 0 to 0 is 0 divided by 2. So I can write fc is equal to 0 to 2 fx dx upon 2, and it is given that this integral is less than f2. So that means there exists a point c in this interval 0, 2 such that the value at this point c is less than the value at 2. So that means f cannot have a minimum at x equal to 2, and that's your option number C. Now question number 21, it says in a triangle ABC, 3 sin A plus 4 cos B equals 6 and 4 sin B plus 3 cos A is equal to 1. So what I'll do is I'll write 9 sin square A plus 16 cos square B plus 24 sin A cos B, and this is 36, and I'll square the second equation also. So I'll get 16 sin square B plus 9 cos square A plus 24 sin B cos A, and this is equal to 1. Now I'll add both of them. So now 9 sin square A plus 9 cos square A, it'll be simply 9. 16 cos square B plus 16 sin square B, it'll be 16. And then plus 24, this is sin A cos B plus cos A sin B. So it is simply sin A plus B. And this is equal to 37. So I'll write 24 sin A plus B, and this value 25 and 37 minus 25 is 12. So I can write sin A plus B as sin pi minus C, and this is 1 by 2. So I'll write sin C is equal to 1 by 2. So that means this angle C is either 30 degrees or angle C is 150 degrees. Now we have both the options, 30 degrees and 150. Now which of the following options is correct? Now if I'll choose C as 150 degrees, then in that case we know that A plus B will be 30. Now if I look at maximum value of 3 sin A plus 4 cos B. So I know that this cos B, it will maximize at B equals 0, and in that case value of A will then be 30. So if I'll put A as 30, I'll get this as 3 by 2 plus 4 and it'll be simply 5.5, which is less than 6. So that means this angle C cannot take a value 150 degrees. So the only option possible in this case is C equals 30, and that's your option number A. Now in question number 22, we are given this matrix A, which is cos theta minus sin theta and cos theta. We need to find A to the power n. So first I'll find A square. So A square simply will be cos theta minus sin theta cos theta into cos theta minus sin theta, and then this is cos theta. So if I'll multiply it, I'll get cos square theta minus sin square theta, which is cos 2 theta. Here I'll get minus sin theta cos theta minus sin theta cos theta. So I'll get minus sin 2 theta. So here again I'll get sin theta cos theta. So again I'll write it as sin 2 theta. And here again I'll get cos 2 theta. In the same way, if I'll calculate A cube, I'll get cos 3 theta minus sin 3 theta, sin 3 theta and cos 3 theta. So I can simply write A to the power n as cos n theta minus sin n theta, and here will be sin n theta and then cos n theta. We can verify the result using principle of mathematical induction also. Now in this question, we need to find A100. Now A to the power 100 will be cos 100 theta minus sin 100 theta, sin 100 theta, and then cos 100 theta. Now theta here is 2 pi by 7. So if I write 100 theta will be simply 200 by 7 pi. So I can write it as 28 pi plus 4 pi by 7. So 28 pi, it's a multiple of 2 pi. So it won't change sine or cos. So I can write this A to the power 100 as cos 4 pi by 7 minus sine 4 pi by 7 sine 4 pi by 7, and this is cos 4 pi by 7. I can also write it as cos 2 theta minus sine 2 theta, and then cos 2 theta, which is nothing but A square. So that means A to the power 100 is same as A square, and that's your option number A. Now question number 23, it's an interesting question. It says, consider all the permutations of 26 English letters that start with Z. So we have this Z, and then we have these 25 places. Now in these places, we have to arrange remaining 25 letters in such a way that number of letters between Y and Z must be less than number of letters between Y and X. Now first scenario can be when Y is placed next to Z. In this case, number between Y and Z is simply 0. So that means between Y and X, there should be at least one number. So X can take any one position starting from this first one, and it goes all the way up to last one. So how many positions are available for this X? So from these 23 positions, I'll need to select any one position. So this is 23C1. So I'll choose any one random position, and there I'll fix X. So now Z has a position, Y has a position, and X has a position. That means I need to arrange remaining 23 letters in 23 positions. So it can be done in factorial 23 ways. Now, what if there is one letter between Y and Z? So if there is one letter between Y and Z, then between Y and X, there should be at least two letters. So that means now in this case, number of positions which are available for X, there are 21. So it'll be 21C1 into, again, arrangement of 23 numbers. So that's factorial 23, and it'll continue till we have this condition when it is 1C1 and then arrangement of remaining 23 numbers. So total number of such permutations, it is given by 23C1 plus 21C1, 19C1 and plus 1C1 into factorial 23. Now I can write it as factorial 23 into, now this is 1 plus 3 plus 5 up to 23. It is nothing but an arithmetic progression. So I can write it as n by 2. Now n in this case is 12 by 2 and then a plus l. So this is 1 plus 23. So I'll get this as factorial 23, and this is 24 into 6. So I'll write it as 6 into factorial 24, and that's your option number B. Now in question number 24 it says, let P and Q be two vertices of a regular polygon having 12 sides such that PQ is diameter of a circle circumscribing the polygon. So that means I have one point which is P, and this P is 1 by root 2 and 1 by root 2, and then we'll have this point Q which is minus 1 by root 2 and minus 1 by root 2. Now this point, the midpoint, will be at origin. Now if I'll calculate radius of this circle is simply 1. Now if I'll draw the axis, then this angle is 15 degrees. Any vertex on this polygon must have an angle which is 15 degrees and plus n into 30 degrees, because the angle between any two successive vertices is 30 degrees. Now I can write any random point as cos theta sin theta. Now if I'll consider this point D, then this point D is actually, this is x negative and y positive. So basically it is second quadrant, and here this value is cos 120 degrees sine 120 degrees. So if I'll compare this theta, then I'll get 15 plus n into 30 is equal to 120. So n into 30 is equal to, now 120 minus 15 is 105, and 105 divided by 30, it is 3.5, which is not an integer. So that means there cannot be a point whose coordinates are minus 1 by 2 and root 3 by 2. Now question number 25 says, if A, B, C are real numbers such that A is equal to A square plus B square plus C square, we need to find smallest possible value of C. Now we know that we can write this equation as a quadratic equation in A. So I'll write A square plus A plus B square plus C square equals to 0. Now since A is real, that means D is greater than or equal to 0. So I'll write 1 minus 4 B square plus C square, it should be greater than or equal to 0. So I'll write B square plus C square is less than or equal to 1 by 4. Now I can write B square as 1 by 4 minus C square. Now minimum value of C square is 0. So that means I can write B square must be less than or equal to 1 by 4. So that is mod of B is less than or equal to 1 by 2. So from here I'll write this B should lie between minus 1 by 2 and plus 1 by 2. So what is the smallest possible value of B? So smallest possible value of B in this scenario is minus 1 by 2. Now question number 26, it says, consider this function fx. We need to find continuity and differentiability of this function at x equal to 0. Now first we'll check continuity. I'll find this limit x tends to 0 x upon e to the power x minus 1. Now this is standard limit, this is 1, and which is equal to f0. So that means this function is continuous at x equals to 0. Now we'll need to find its differentiability. So first I'll find its left hand derivative. So I'll find f dash 0 negative. So it'll be limit h tends to 0 f minus h minus f0 upon minus h. So I'll write it as limit h tends to 0. Now what is f minus h? It will be simply minus h e to the power minus h minus 1 minus f0 is simply 1 upon minus h. So I'll write this limit as limit h tends to 0 minus h minus e to the power minus h plus 1 upon minus h into e to the power minus h minus 1. Now I'll use expansion formula for e to the power minus h. So I'll write this limit as limit h tends to 0. I'll write minus h and then I'll also write plus 1 and minus. For this e to the power minus h, I'll get 1 minus h plus h square upon factorial 2. And in the denominator, I'll write minus h, and this is 1 minus h plus h square upon factorial 2 minus 1. Now here 1 will cancel, h will also cancel. So what is the minimum power of h in the numerator? So minimum power of h in the numerator is h square. Now in the denominator also, this 1 and 1 will cancel. So again in the denominator, minimum power is h square. So answer to this limit simply will be coefficient of h square in the numerator, so which is minus 1 by 2, and coefficient of h square in the denominator, which is 1. So that means left hand derivative is simply minus 1 by 2. Now we will find right hand derivative. So right hand derivative f dash 0 positive will simply be limit h tends to 0 fh minus f0 upon h. So I'll write this as limit h tends to 0 h upon e to the power h minus 1 minus 1 upon h. I'll write it as limit h tends to 0 h minus e to the power h plus 1 upon h into e to the power h minus 1. So again I'll use expansion formula. So I'll write limit h tends to 0. So this is h plus 1 and then minus 1 plus h square upon factorial 2, and here it will be h 1 plus h square upon factorial 2 minus 1. So here 1 and 1 will cancel. Here also 1 and h will cancel. So again minimum power of h in the numerator is h square, and the denominator also minimum power is 2. So what is the coefficient of h square in the numerator? It is minus 1 by 2. In the denominator it is 1. So in this case also right hand derivative is minus 1 by 2. So left hand derivative and right hand derivative, they are finite and they are equal. So that means this function is differentiable at x equal to 0 and f dash 0 is minus 1 by 2. Now question number 27, it's a wonderful question. It says this function fx is defined as maximum of mod x minus y upon x plus y plus 1 when y lies between 0 and 1 for x lying between 0 and 1. So for this function, I'll consider this first case when y is less than or equal to x. So in that case, I can write this function as some function g as a function of y, which is, now since y is less than x, I can simply write it as x minus y upon x plus y plus 1. Now in this range from 0 to x, I'll need to find maximum value of this function. So what I'll do is I'll differentiate this function. So I'll find g dash y. So it'll be x plus y plus 1 and then minus 1 and minus x minus y upon x plus y plus 1 whole square. So in this case, I'll get minus 2x minus 1 upon x plus y plus 1 whole square, which is less than 0. So that means in this interval from 0 to x, this function gxy, it is a decreasing function. Now if the function is a decreasing function, then the maximum value of this function occurs at starting of this interval. So that means maximum value of gxy is equal to gx when y is 0. So if I'll put y as 0, I'll get this function as x upon x plus 1. Now I'll take the second case. Now the second case when x is less than y and this is less than equal to 1. Now in that case, this function of y, it is given as, now here since y is greater than x, so I'll write it as y minus x upon x plus y plus 1. Now if I'll differentiate, I'll get x plus y plus 1 minus y minus x upon x plus y plus 1 whole square. So here will be 2x plus 1 upon x plus y plus 1 whole square, which is greater than 0. So that means in this interval, this function, it will be an increasing function. Now if the function increases, then the maximum value of this function occurs at end of this interval. So that means in this case, maximum value of gxy will occur at y equals 1. If we'll put y as 1, we'll get this as 1 minus x upon x plus 2. So I can write this function fx as x upon x plus 1 when x lies between 0 and a, and this is 1 minus x upon x plus 2 when x lies between a and 1. Now how do I find this a? Now we know that this fx, it always takes maximum value. So there'll be this point a where the value of this first function must be equal to the value of this second function. So that means at x equal to a, this a upon a plus 1 must be equal to 1 minus a upon a plus 2. Now if I'll solve this condition, I'll write a square plus 2a is equal to a plus 1 minus a square minus a. So I'll get it as 2a square plus 2a minus 1 equals to 0. Then the value of a is minus 2 plus minus, and this is 4 plus 8 upon 4. So it will be minus 1 plus minus under root 3 by 2. Now this a, it must lie between 0 and 1. So that means the value of a possible in this case is minus 1 plus root 3 upon 2. So that means this function fx is defined as x upon x plus 1 when the value of x lies between 0 and root 3 minus 1 upon 2. And this function is 1 minus x upon x plus 2 when the value of x lies between root 3 minus 1 upon 2. Now we'll need to find where this function increases and where this function decreases. So I'll differentiate this function. So if I'll differentiate this function, I can write f dash x as x plus 1 minus x upon x plus 1 whole square, which is 1 upon x plus 1 whole square when x lies between 0 and root 3 minus 1 by 2. And if I'll differentiate the other one, I'll write x plus 2 whole square, x plus 2 into minus 1, and then minus 1 minus x, which is minus 3 upon x plus 2 whole square when x lies between root 3 minus 1 upon 2 and 1. So which means when x lies in this interval, this derivative is always positive, and the other interval, this derivative is always negative. So that means this function is strictly increasing on 0 to root 3 minus 1 upon 2 and strictly decreasing on root 3 minus 1 upon 2 and 1. So that means answer to this question is option number C. Now question number 28 says, for a positive real number alpha, let S alpha denote the set of points x comma y such that mod x to the power alpha plus mod y to the power alpha is equal to 1. And it says a positive number alpha is said to be good if the points on S alpha that are closest to origin lie only on the coordinate axis. Then we'll need to find this condition on alpha. Now we are given this curve which is mod of x to the power alpha plus mod of y to the power alpha equals to 1. Now this curve, it is symmetric about x-axis as well as about y-axis. So what I'll do is I'll solve the question in first quadrant and then it'll remain the same for all of the quadrants. So I'll simply choose the condition when x is greater than or equal to 0 and y is greater than or equal to 0. So I'll write this as x to the power alpha plus y to the power alpha equals to 1. Now since we are discussing distance from origin, so what I'll do is I'll express this x as r cos theta and I'll express this y as r sin theta, where this theta, it varies from 0 to pi by 2. So if I'll put the value of x and y, I'll write r to the power alpha and this is cos theta to the power alpha plus sin theta to the power alpha and this is equals to 1. So I can write r to the power alpha as 1 upon cos to the power alpha theta plus sin to the power alpha theta. Now I need to minimize this distance r. So I'll differentiate. So I'll write alpha r to the power alpha minus 1 dr upon d theta, and here I'll get minus 1 upon cos alpha theta sin to the power alpha theta whole square, and here I'll get alpha cos alpha minus 1 theta into minus sin theta and plus alpha sin to the power alpha minus 1 theta into cos theta. Now here I'll take minus sin theta into cos theta common. I'll take this alpha also common. So I'll write alpha sin theta cos theta, and here I'll get cos alpha minus 2 theta minus sin alpha minus 2 theta upon cos alpha theta plus sin alpha theta whole square. So if I'll put it equals to 0, so the critical points that I'll get is either sin theta is 0 or cos theta is 0 or cos alpha minus 2 theta minus sin alpha minus 2 theta is equal to 0. So from here I'll get the value of theta as either 0 or pi by 2 or pi by 4. So I'll put these points on number line. So this is 0, this is pi by 4 and this is pi by 2. Now in the question it says the point closest to origin must lie on coordinate axis. So that means I must get a minima when theta is either 0 or pi by 2. So that means at 0 the sign of derivative must change from minus to plus, and then again at pi by 2 it must change from minus to plus. So now in this case what I must ensure is when theta lies between 0 to pi by 4, the sign of this expression must be positive. So now we know that in that case sin theta will be positive, cos theta will be positive. Now in 0 to pi by 4, cos theta is greater than sin theta. So this expression, it should also be positive. This expression will be positive when alpha minus 2 is greater than 0. So that is, this expression will be positive when alpha is greater than 2. So we'll have a minima at 0 and pi by 2 only when the value of alpha is greater than 2. So answer to this question is all alpha greater than 2 are good and others are not good. That's your option number C. In question number 29 it says a water pitcher has a hemispherical bottom and a neck in shape of two truncated cones of same size. Now various dimensions they are given. So radius of this hemisphere, it is 20. Height of these cones, it is 10 each. Now this smaller radius R1 is 15 and this bigger radius, this is 20. Now first what we'll do is we'll find volume of this pitcher, and that is equal to volume of water. So volume of water contained in this pitcher will simply be, now it is 2 by 3 pi r cube, and then plus we have two same truncated cones. So I'll write 2 times pi by 3 and then r1 square plus r2 square plus r1 into r2 into h. H in this case is simply 10. So I'll take 2 pi by 3 common, and then r here is 20. So I'll write 20 cube. 20 cube is simply 8000, and then plus 225 plus 400 plus 300 into 10. So I'll get this value as 11,500 pi centimeter cube. Now it says, if a solid cylinder with diameter 24 centimeter and height greater than 60 is inserted vertically into the pitcher as far down to the bottom as possible, how much water would remain in the pitcher? So now we have this cylinder which is in this pitcher. Now we know that this radius, this is 20. Radius of this cylinder is 12. So we can find the small h. So in this case, this small h will simply be under root of 20 square minus 12 square. So there will be 400 minus 144, that is under root 256, that is 16 centimeter. So the height which is immersed in this pitcher is 16 plus 10 plus 10. So it will be simply 36. So what is volume of the cylinder? So volume of the cylinder will be pi r square. R square here is 12 square into 36, which is 5184 pi centimeter cube. Now this is also volume of water displaced by this cylinder. So if we have to find volume of water which is remaining in the pitcher, then it is given by this total volume, which is 11,500 pi minus 5184 pi, and which is equal to 6316 pi centimeter cube, and which is your option number A. In question number 30 it says this f sine x by 2, it is equal to sine x plus cos x. Now I can write f sine x by 2 as 2 sine x by 2 into cos x by 2, and I can write cos x by 2 as 1 minus sine square x by 2, and plus, now cos x is 1 minus 2 sine square x by 2. So what I'll do is I'll replace this sine x by 2 with some other variable, say z. So I'll write fz is equal to 2z into under root of 1 minus z square plus 1 minus 2z square. Now we need to find the value of f 3 by 5. So it will be 2 into 3 by 5, and here will be 4 by 5 and plus 1 minus 2, and z square is 9 by 25. 24 minus 18, it is 6. So it will be 6 upon 25 plus 1, which is simply 31 upon 25, and that's your option number B.